The difference between raw manure and composted manure is raw manure is sold on a mineral content only, on a lab assay that indicates NP and K values, while composted manure will have a comparable mineral NPK value. The greatest value of composted manure is the biological properties of the correct microorganisms of bacteria, fungi, protozoa, nematode that are transferred into a soil that needs that proper restructuring of a biological field. That is 100 times more valuable than the mineral content coming from NPK, because within a few years, your mineral content is depleted, whereas a proper biology inoculation can last for decades. The next comparison between raw manure and composted manure are the mineral contents. In the raw manure, our mineral contents are soluble and leachable, which means they are exposed to the highest loss possibilities in the environment. Rain, water, other microbes accessing that soluble mineral base reduces the mineral content available for plants. On the other hand, composted manure, the minerals are restructured through the decomposition into organic structures and forms which are far more retained in the soil reserves. These are retained in the organic structures and also the microbial bodies, which are not leachable. And so we retain our mineral content in a far superior form through the process of composting. The minerals in raw manure are often held in an oxidized form, which are not readily plant available. The minerals in a composted manure are retained in a reduced form. This means they are far less leachable because of their retention in organic matter structure in the microbial bodies, but they are in a reduced form which is more available for the plant's utilization. Oxidized minerals cannot be utilized by a plant. Reduced minerals are the form that the plant utilizes its major and its minor or trace element micronutrients. Raw manure, because it sits for a period of time before it's often applied to the field in the springs or the falls, goes through a putrefaction process, an anaerobic pathogenic microorganism structure that actually creates a lot of very toxic and harmful pathogens, poisons, and aldehydes, which then are moved into the field environment, which reduce plant growth and affect biology populations. With composted manure, the aerobic microorganisms have a restructuring of not only the minerals, but they restructure the microbial populations. They kill the pathogens. They reduce their ability to function whatsoever in a composting operation. Raw manure is highly anaerobic. Anaerobic microorganisms are those that function without air in a high moisture, reduced oxygen environment. Composted manure is completely aerobic. Aerobic microorganisms require oxygen. They're like us. And so they operate in a very aerobic environment. And so we have a complete switch of the biology. Raw manure produces anaerobic pathogens that then are moved to our soil. Composted manure produces all of the aerobic beneficials so that we have the bacteria, the fungi, the protozoa, the nematode, which are not at all like the biology populations in raw manure. Pathogenic anaerobes always, without exception, produce life-reducing toxic elements. Beneficial microbes, aerobic biology, on the other hand, produces very life-sustaining and life-promoting compounds such as enzymes, vitamins, amino acids, organic acids such as plant regulators, growth stimulants, antioxidants, naturally occurring antibiotics. And these sustain and promote life, which is completely opposite of the anaerobic pathogens and their production. Another major difference in our raw manure is the odors that are created. Anaerobic pathogens, through the process of putrefaction, are not properly decomposing the organic materials, and they take the minerals, such as nitrogen, and volatilize it as ammonia. The phosphate is volatilized as phosphine gas, which is extremely toxic. The hydrogen and the sulfur is volatilized as hydrogen sulfide. And this is a dramatic loss of our potential nutrients or minerals that should be retained for soil reserves, not put back up into the atmosphere. In a composting operation, our beneficial microbes do not volatilize the minerals. They retain them through their metabolism and through the reconstruction of organic matter and putting them into their microbial bodies. Our nitrogen, our phos, our calcium, our potassium, our sulfur, our trace elements are all retained in a organic, stable form that are not leachable, and so we have a far greater retention of minerals in the proper form. Raw manures are very high in soluble salts, which are detrimental to root systems, they're detrimental to soil biology, and they are very leachable, which means they can be easily lost into other water bodies. Composting that manure through an aerobic process where the microbes require oxygen, those salts are restructured into an insoluble reserve so they do not affect other soil microorganism populations, and they are not toxic to the plant roots, and they are not leachable. Raw manure translocates a great number of anaerobic pathogens and pathogenic compounds into our soil. Composted manure eliminates the presence of pathogens, and aerobic microorganisms, which come from the composting process, have the ability to restructure our soil aggregates. That means taking compacted soils and creating spaces for air and water, and also the reduction in compaction so that we have far greater root growth. The beneficial microorganisms set up a nutritional network and provide those minerals in the proper form for plant uptake. Raw manure is extremely high in bacterial populations. When added to the soils, high bacterial populations stimulate weed growth. The salt content stimulate high salt-tolerant plants. The combination of these are destructive to the crops that we want to grow. Composted manure with a balanced bacterial population, that of approximately equal bacteria to equal amounts of fungi, reduce the environment that encourages weed growth. The salts are restructured, and the beneficial microorganisms then set up the soil structure for better aggregation, oxygen, water retention, root growth, and plant health. Raw manure, because of its very high biological oxygen demand, has to deplete the soil of its oxygen reserves in the process to further decompose it. This sets up the environment for pathogens which produce toxins, and now we've lost our oxygen for our plant life and our beneficial microbial populations. High biological oxygen demand is very destructive in soils and aquatic systems. Government agencies now monitor farm runoff for materials that affect biological oxygen demand in other systems. They can be very costly and have heavy fines. Properly composted manure has virtually no biological oxygen demand. Through the process of proper decomposition, the oxygen required to complete the decomposition process came from the air. So if our composted materials were to ever enter another environment, they would have no impact on the aquatic life or the plant life in that environment. In raw manure, there is very little biology population that is proper for beneficial plant growth. In properly composted manure, we structure our microbial populations towards the intended plants that are going to be grown. For example, grasses, vegetables are more bacterially dominated. Grasses require approximately 3 times more bacteria than fungi. Vegetables, for every bacteria, approximately 3/4 of a fungi in ratio. Our row crops require a balanced biology, which is for every 1 bacteria, 1 fungi. When we get into our woody plants, those that have vines and more structure, for every 1 bacteria, they now require 5 to 10 fungi. In our fruit trees and our ornamental trees, for every 1 bacteria, we require as high as 200 to 250 fungi. In our conifers, for every 1 bacteria, they require as much as 500 fungi. And in our old growth forest, for each bacteria, there can be as high as 1,000 fungi. None of the beneficial soil biology balances required for many various plants are present in any raw manure form. They have to come through composted materials. Whether it's organic matter or whether it's manure, the proper biology has to be grown and sustained in that decomposition process so the inoculation is proper for the plant. By using the properly composted manures or materials, you are adding the right biology and mineral structure to your crops that provide improved nutrition, reduced pathogen populations, improved soil structures. These inoculated biologies will have a long-lasting beneficial contribution to your farm for years and decades.